Let's look at these final few examples. For a national poll of 2,345 people reached to answer the following series of questions. Of the 2,345 people reached, 11,123 agreed to be interviewed. What proportion of people did not participate in the poll? Okay, so that's going to be not participating in the poll is going to be 2,345 minus 1,123, and that gives me 1,222. Okay, so now if I take this, let's say, okay, so we got 1,222, divide that by 2,345, and that gives me 0.5211. Okay, so around 52% of the people, a little more than 52% of the people did not participate. And what this is known as? This is known as non-response rate. Okay, so that's what a non-response rate is. Now, if too many people are randomly selected to participate in an interview, decide not to participate, there's a great chance that a poll may result in a type of bias known as non-response bias. Now, this is only true. So usually when you have this non-response rate is high, then all of a sudden this triggers this non-response bias. But it doesn't mean the result is unbiased. So how do you know if it's biased or not? The answer is you'll never know. But what we're afraid of is the following. Maybe I should put in the positive spin. If the people that did not participate in the poll are representative of the population, then the result is representative. Why is that? Because if the people that refuse to participate are representative, then what's left over is representative. So all we care about is that our sample is representative. What would happen, though, is because the sample size is smaller, the estimate for our parameter will not be as good. But that doesn't mean it's not biased. It just means that it's not as good of an estimate. Okay, that's all that means. Okay, so the questions in any poll must be carefully crafted so as to not lead the person to be interviewed to a specific response. Even the order of the questions must be carefully crafted. Otherwise, this is not done. We may be getting results due to simply how the questions were asked, or the order in which the questions were asked, leading to what is known as, and this is called response bias. Okay, so response bias is just that the way things were worded leads you to a particular response, and in a court of law, this is known as, leading the witness, right? So when you see the lawyer's objection, maybe that one of the objections is the leading the witness. The way the question is asked will solicit a particular response, and not the response that generally the person would give. Let's look at this next one here. Below is a map of the Moda Center, home of the Portland Trailblazers professional basketball team. Right now, you can go to StubHub or SeatGeek or any other online system, Ticketmaster, get tickets for the Trailblazers game. Here's my question. What is the average cost of a ticket for a sold-out game at the Moda Center, excluding the fancy club seats? Okay, so that's what we're after. Suppose we found the cost of every seat in the stadium, let's say for a particular game, and calculated the average. Is this value a parameter or statistic? So again, we took every seat as being, so this is what we just did, was do a census. And because we did a census, then this is going to be a parameter. Okay, and we've already did this in the past, but what is a symbol used to represent it? So this is kind of like a little reminder where we've been. So because this is a parameter and we're looking at the average price, or we'll see next week, we'll always call this the mean, we're going to use the population symbol for the average, which is mu. So let's say it was $45, it would be this. Also, that's the symbolic way, using the Greek letter. Sometimes later we'll also use this E for the expected value. The expected value is sometimes known as the mean. And if we called E X the cost of its ticket, then this will be called E of X. Okay, and this again is the mu or the E of x is really interchangeable symbols. Suppose that we only want to estimate this number. So now we're not trying to get the exact number, just estimate the mean seat, the seat cost, the average cost, come up with a sampling process that is unbiased. So we have several approaches. If here's the Trailblazers court, and one thing we do know is the closer you get to the court, the more expensive seats. So this seats here are definitely more expensive, and as you go up, they get less expensive, and so on. By the time you reach this level, it becomes the cheapest seat in the house, or you found in the back somewhere, or even at the very top. Well, the very top usually, the cheapest typically. Not quite. But let's suppose I did this. I'm going to just grab this grouping right here. In fact, change my thing. I'll grab here. And I'm going to grab this right here. And then within each, I'm going to sample. Well, because the way I grab each of these is sort of representative of the entire stadium. So this would be considered a cluster, and a cluster. Okay. Suppose instead I did this, I'm going to grab randomly select seats from here, maybe from here, and then I'm going to go over here. So now what I'm doing is from these seats or these sections that are very close, I'll pick one. Then from this next level here, I'm going to pick one. From the next level, I'm going to pick one, and then combine these. So now this is because of the way I'm separating the stadium, these levels here are the stratus. Okay, each one very particular to the average cost price. So that would be another way of doing it. If because all the seats here are enumerated, it is possible to pick go through a random number generator and pick, let's say, 300 seats at random, and then so that would be an example of a simple random sample. And again, this is just to give you an overview of what we've done already. If you, for example, also decided to, say, pick a seat right here, pick one seat completely at random, so we pick this one, and then we move every 200 seats over, so 200 seats, and 200 seats, and go in a circle, then go to the next level and pick again, skipping every 200 seats. So that would be an example of a systematic sampling method. Suppose I show up to my seat here, and I just ask the people around me, like, how much your ticket cost? How much ticket cost? Well, this would be a convenient sample because I'm just really, this is not randomized. I just kind of matter of factly just start asking people around me because, it's a convenient thing to do. But of course, this is not a good method, nor will it produce anything near what the actual average will be.